Hello friends, this video on aldehyde ketones and carboxylic acid part 2 is brought to you by examfear.com. No more fear from exam. Since aldehyde and ketone has a lot of similarities in the chemical reaction, I have bucketed the whole chapter into two parts. The first part is aldehydes and ketones, and the second part talks about the carboxylic acid because they're a little different. But aldehydes and ketones has a lot of similar chemical and physical properties. So the first bucket is aldehyde and ketone, and as I already told you, the definition of aldehyde is you have a carbonyl group and bonded to at least one hydrogen. Correct? So if you have at least one hydrogen, it is my aldehydes. And ketone, you have two other carbon. I'll explain once again. I have my carbonyl group. Carbon has 4 valency, so the 2 are left. So in this minimum, I should have one hydrogen that is fixed. Here I can have anything. I can have R or I can have H. This is my aldehyde. To talk about ketone, so in this ketone it says that both has to be some R. This is my ketone, right? So both the bond of this carbon, this is anyway used. Now we have only 2 bonds left. So both has to be bonded to carbon, right? This is alkyl group, so it's a carbon. This is my ketone. So let's start with the common name of aldehyde first. The common name of aldehyde is generally derived from the acids, carboxylic acid. Actually, if you see the history of chemistry, carboxylic acids were something which were discovered a lot earlier. And since when these carboxylic acids were discovered, at that time the IUPAC naming convention was not there. At that time common name used to exist, and that's why you will see a lot of carboxylic acids have a good number of common names. And aldehydes also derives their name from carboxylic acids, the common name of aldehydes. If you see, the common names of the most of the aldehydes are derived from the common names of the corresponding carboxylic acid. And we'll discuss this in carboxylic acid, since carboxylic acids was a lot of carboxylic acids were discovered before IUPAC came into picture. That's where a lot of carboxylic acids have their common name. And this aldehydes, you derive the common name of aldehydes, you derive from their corresponding carboxylic acids. Common name of carboxylic acids, actually, right? So you have to replace the IC in the carboxylic acids with aldehyde. So we'll discuss more about this in the carboxylic acid part, where we'll discuss the common name of the carboxylic. And this is how the aldehyde looks like, right? IRCOH. This R can be any alkyl group. It can be hydrogen also. Right? So with this, if you see, this is formaldehyde, right? So HCOH, this compound is derived from HCOOH. Correct? Now for this compound, the common name is formic acid. And we'll discuss this in the topic where we'll discuss the common name of carboxylic acids. So for this compound, the common name is formic acid. So remove this IC acid and add aldehyde. So it becomes formaldehyde. So this form we have got from this IC, if you delete it off, and acid will let go. So form and add this word aldehyde. So you get formaldehyde. Correct? So this is how you get. You replace the IC of the acid, formic acid, you replace the IC acid. So you have to remove it off, and you get form, and you add this word aldehyde, you get formaldehyde. That is how you derive the common name. Please note, I am talking about the common name. I have not yet started with the IUPAC name. And the location of the substituent carbon in the chain is indicated by the Greek letter alpha, beta, gamma, etc. So if this is my CO group, right? So alpha is the one which is directly linked to the aldehyde group. This is my alpha, this is my beta, this is my gamma. So in this case, the common name of this, to be specific, will be, at beta I have a bromo, so it will be beta bromo, yeah, beta bromo, and it will be with but. This is but butylaldehyde. This is the common name. Please note, this is the common name of this compound. Similarly, for this CH3COH, this is derived from acetic acid, so it will be acetaldehyde. This is derived from benzoic acid, so it is benzaldehyde. It will be more clear when we will discuss carboxylic acid's common name. So this is how you derive the common name. Generally, common name of acetaldehyde or aldehyde is derived from the corresponding carboxylic acid. You replace IC of the acid with aldehyde. Correct? Acetic acid becomes acetaldehyde, formic acid becomes formaldehyde, benzoic acid becomes benzaldehyde. Now we'll talk about the IUPAC name of the aldehyde. Please note, the last slide we talked about the common name. Now we'll talk about the IUPAC name of the aldehyde. It is more formal and you have better ways actually. So in this case, you derive, see in the IUPAC name, generally the IUPAC name for any of the compound is derived from the alkanes, right? So here also this is derived from the corresponding alkanes by replacing E with Al. Please note here, the common name is a little weird, right? Because the common name depends on the trends. So for aldehydes, the common names are derived from carboxylic acid, because when the IUPAC name was not there and the common name was in the fashion, that time carboxylic acids were the base actually, and thus the common names derived from the carboxylic acids for aldehyde. But IUPAC name came later. At that time, alkanes, alkenes, alkynes, carboxylic acid, everything was there. So, and in most cases, the IUPAC names are derived from the alkanes by replacing E with Al. See, for example, for this scenario is you have this CH3COOH, right? So this is derived from ethane. 2 carbon ethane. So remove this word E and make it Al. It becomes ethanol. So IUPAC name of this compound is ethanol. Correct? Similarly, for example, HCOOH, this guy has come from methane, 1 carbon, right? So methane, you replace E with Al, it becomes methanol. Now, what if it has a branch, right? It's a long branch chain. So in this case, in the case of chain, it is numbered from the carbon of the aldehyde. We'll take some examples for this. And as we have seen in the other cases, here also, when you want to write it, it is in alphabetical order. All the substituents which we prefix, it's all in alphabetical order. It's similar thing in other chain hydrocarbon. When you have this aldehyde group attached to a ring, then you suffix carbaldehyde after cycloalkane. We will see all these examples to understand these. And as is the case of the normal chain, here also for the ring chain, the numbering will start with the aldehyde groups. We'll take some example, for example, CH3COH. We have already taken this actually. This is nothing but ethanol, right? Because this is derived from ethane. So this is ethanol. Correct? So you take ethane, you cut this E and put Al. So this becomes ethanol. Let's take the chain one. So let's take this compound CH3, CH2, CH, COOH, and here let me put a CH3. So now in this case, I have to start numbering from this position. This is 1, this is 2, 3, and 4. This is my longest chain. Correct? So it will be what? At 2 I have a methyl, methyl, and then I have 4 methylpro-butanol. This will be the name of the compound. Correct? See, the numbering starts from this compound, the carboxyl group. So it's 1, 2, 3, 4. At 2 I have methyl group. If I have more of prefix, again I'll follow the alphabetical order. We'll take more examples to understand this. For example, in the same scenario, I have, let's suppose, a bromine here. Or let me draw a new structure actually. I have CH3, CH, here I have Br, CH, CH3, COH. Again, let's number, this is the longest chain, let's number from here. 1, 2, 3, 4. So I have 3, I have bromine, and 2, I have methyl, right? So B comes A, see I have bromine, I have methyl, right? A, B comes first. So I'll first write 3 bromo, it will be 3 bromo, and then 2 methyl, and then it is same thing, butanol. So the naming is not based on this number 2 or 3. The naming is based on these methyl group, bromo group, and this is all alphabetical order. This part is also done. Let's take one example of this ring. So let's suppose I have this compound, cyclic compound, and here I have COH. Correct? So I have a cyclohexane and a carbaldehyde. So this name will be cyclohexane first, I'll write. So you see, added after the full name of cycloalkane, this is cyclohexane, and then I'll write carbaldehyde. So this is the IUPAC name of this compound, cyclohexane carbaldehyde. This is my COH actually. If you are not able to see clearly, I can draw COH here. Yeah, this is the compound, cyclohexane carbaldehyde. Correct? So here also, if I have some beta, alpha, or methyl or ethyl group attached, for example, if I have a methyl group attached here, let's suppose here, CH3, numbering starts from here, 1, 2, so it will be 2 methyl cyclohexane. So I covered this, and the numbering part also I covered. So if I have a methyl group attached here, so it will be 1, the numbering starts from this position, so it will be 1, 2 methyl cyclohexane carbaldehyde. So with this is the basics for the IUPAC name for aldehydes. So let's take some examples, or let's do some practice. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.